All right, so this video is going to go over some basic differentiation rules. So first one, power rule. We use this one all the time. So anytime you have a variable raised to a power, you're going to multiply by that power. So n multiplied by x, and then you're going to subtract 1 from the power. So to the n minus 1 power. All right, let's do some examples. So we have x cubed, so f prime, the derivative of f is equal to 3 multiplied by x to the second power, which is 3 minus 1. All right, so that one's a pretty basic one. It's right there in front of your face. A lot of the other ones, you have to do a little bit of manipulation first. Okay, so this one, square root of x, is a power rule in disguise. So remember that a square root is the same thing as x to the 1/2 power. Okay, so we can multiply by 1/2 in the front, 1/2 times x, and then to the 1/2 minus 1 power. Okay, I didn't show my work on the last one just because we kind of did it in our head there, but this is the 3 minus 1 power. So 1/2 minus 1. All right, so we have 1/2 times x, and then 1/2 minus 1 is negative 1/2. 1/2 minus 2/2 is negative 1/2. And then we never want to leave a negative exponent in our answer. So I would rewrite this as 1 on top divided by 2, and then we're going to move that x into the denominator, x to the 1/2 power, like that. Okay, you can go back to square root form if you like. You can leave it like this. You could rationalize. There's a lot of other stuff you can do. That happens a lot in calculus where it's like, where do I stop? All right, you stop where, as long as there's a couple kind of rules that you follow, no negative exponents, no complex fractions, but as long as you follow those rules, you're probably pretty good. This would probably be what I would expect to see on a multiple choice answer, would be that. Okay, so that's where we're going to stop there. All right, this one, you can see the power, but it's in the denominator. So there is a little bit of rewriting to do. And if you're in the denominator, similar to the last problem, we had a negative exponent, which we put into the denominator. Well, now we're going to take it out of the denominator. We're going to make it a negative exponent like that. Okay, and then apply the power rule. Multiply by the exponent, negative 4t to the negative 4 minus 1. So that's negative 4t to the negative 5. All right, and then again, no negative exponents in our final answer, so we have our negative 4 on top divided by t to the 5th power on the bottom. All right, this one is going to be a rule that you're just going to memorize, but technically it is a power rule. So I don't see an x here at all. So when you don't see an x, it's x to the 0 power. And so if I multiply by the exponent, I would get 0 times 5x to the 0 minus 1. Okay, so that's x to the negative 1, which we can move down, but none of that matters because we're multiplying by 0, which means our answer is 0. So if you ever take the derivative of a constant, you're going to get 0. Derivative of a constant is 0. All right, last one. This one's just a basic power rule, very similar to letter A, except there's a coefficient in front. So if you have a coefficient in front, just multiply the numbers together. So we're multiplying by 3, you get 15. X to the 3 minus 1, which is 2. So 15x squared. So this is the derivative of a constant rule, which we just learned is 0. Okay, now we spent a lesson or two defining derivatives using limits. So many of the limit properties are going to also apply when you have derivatives. Now I said many, not all. Okay, the sum and difference properties apply exactly the same way, but the product and quotient properties from limits do not apply the same way. Okay, so we're transporting some of the rules over, but not all of them. Okay, so the sum and difference properties from limits said if we have a sum inside our derivative or inside our limit, we can split it into separate ones. So we can do the derivative of f of x plus the derivative of g of x. So you're just taking the derivative of each function separately. Same thing with subtraction. All right, and so that's really powerful because if we get something like a polynomial like this with a lot of terms, what that means is that I can take the derivative of each term one by one, and I don't have to try to take the derivative of this whole thing all at one time. Okay, which would be difficult to do. All right, so take the derivative of this term. So apply your power rule. Multiply by 3, that's 12x. Subtract 1 from the exponent, 2. Now take the derivative of the next term. Multiply by 2, that's negative 10x to the 2 minus 1, which is 1. So I don't have to write 1. All right, here, multiply by 1, so that's plus 7 to the x to the 1 minus 1, so that'd be x to the 0 power, which is equal to 1. So if you're taking the derivative of an x to the first power, you're just going to get the coefficient in front. That's it. And then the derivative of a constant is 0. So this is it. F prime of x is equal to 12x squared minus 10x plus 7. Okay, this one, you cannot take the derivative of a quotient. Well, that's not true. There is a rule for that, but it does not involve the power rule. So it's something that we will cover in our next lesson. But you don't need the quotient rule on this one because this denominator is a common denominator. So you can divide all the terms by x. So this first term, 5x to the 5th divided by x is equal to 5x to the 4th. Subtract the exponents. All right, the next one is negative 3x cubed. 4 minus 1 is 3. Okay, the last one doesn't have an x, so we're going to do what we did on letter C up here. We're going to take that from the denominator, we're going to move it up, and that's going to give us a negative exponent. So we're going to get plus 4x to the negative 1. Now we can apply the sum and difference properties and take the derivative of each term one by one. So multiply by 4, I get 20x cubed. Multiply by 3, I get negative 9x squared. Multiply by negative 1, I get negative 4x to the negative 2. All right, don't leave a negative exponent in your final answer. So the first two terms are good. So those are positive exponents. And then the last term we're going to write as 4 over x squared. Notice that this x squared only goes under the 4. It does not go under the whole thing because that that x only applies to this term. It doesn't apply to these two terms as well. All right, next one. Determine the points at which a given function All right, sorry, I had to pause there for a second. So now we are determining the points at which a given function has a horizontal tangent line. Okay, so we talked about how the tangent line, the slope of the tangent line is equal to the derivative at a point. Okay, so the slope of the tangent line is equal to the derivative. So f prime of x is the slope. And so if we want to have a horizontal line, think about what the slope of that line would be. A horizontal line has a known slope. Okay, the slope of a horizontal line is 0. So what this is saying is that the derivative f prime of x has to be equal to 0. Okay, so anytime you see horizontal tangent line, that should pop into your head immediately. F prime is equal to 0. All right, so let's use our derivative rules and let's find f prime. So derivative of x cubed is 3x squared. Derivative of 12x is minus 12. Set that equal to 0. Do some algebra. 3x squared is equal to 12. X squared is equal to 4. X is equal to plus or minus 2. All right, now we're not done yet. Let's go back up and read our question. Determine the points. Points are an x and a y. Okay, so we have found the x coordinates of two different points where this is true. Okay, now we need to find the y coordinates. So we're going to do f of negative 2. Taking my negative version, so I get negative 2 cubed minus 12 times negative 2. So that's negative 8 plus 24, which is equal to 16. Then I'm going to do f of positive 2 is equal to 2 cubed minus 12 times 2. So that's 8 minus 24, which is negative 16. Okay, we're going to write our answer as a sentence. F of x has horizontal tangent lines at negative 2, comma 16 and positive 2, comma negative 16. And that's it. All right, flip it over on the back. Okay, trig functions. We're going to be able to take the derivative of all of our trig functions, so that's what we're doing here. Okay, sine and cosine follow a circular pattern. So sine x we'll put at the top of our circle. The derivative of sine x is cosine x. Okay, so that's our answer here. The derivative of cosine x is negative sine x. That's our answer here. And then keep the negative. Derivative of sine is cosine. So derivative of negative sine is negative cosine. And then keep the negative. Derivative of cosine is negative sine. So it's negative sine, which is positive sine. So it goes in a circle like that. All right. Derivative of 6x squared is 12x. Derivative of cosine is negative sine, so minus 5 sine x. Again, we're using that sum property where we take the derivative of each term separately. All right, they're telling us about average velocity right here, which we've seen before, f of b minus f of a over b minus a. Average rate of change, I should say, which is also known as average velocity. The instantaneous rate of change is the derivative, f prime at a single point. So for average, you need 2 points on an interval. For instantaneous, you need a single point. Instantaneous rate of change is also called instantaneous velocity. Okay, so f of x is equal to this. Find the average rate of change of f on 1 to 5. So that's f of 5 minus f of 1 over 5 minus 1. All right, so that's okay. Got some arithmetic to do here. 5 cubed minus 3 times 5 squared plus 4 minus parentheses. And plugging in 1's nice because the exponents, you can forget about them. So 1 minus 3 plus 4. All over 4 on the bottom. Okay, I want to actually simplify this one because I want to compare my answer to letter B. All right, so this is 125. 5 squared is 25 times 3 is 75. So minus 75 plus 4. And then inside here is 2. 5 minus 3. So minus 2. Okay, so this is 50, 54, 52. Over 4. 52 cards in a deck, 4 suits, 13 cards of each suit. All right, so that is our average rate of change of the function on the interval from 1 to 5. Instantaneous rate of change, that means the derivative. So this is going to be f prime of x. Okay, so that's 3x squared minus 6x and plus 0. So that's it, 3x squared minus 6x. And we're going to do the instantaneous rate of change at 3. So 3 times 3 squared minus 6 times 3. So that's 9 times 3 is 27 minus 18, which is equal to 9. All right, so you can see how different that is. All right, the average rate of change, and 3 is right in the middle of that interval. Okay, so a lot of times, depending on what kind of function you have, these could be pretty close to each other. All right, but whatever this graph looks like, the average rate of change is a pretty significant difference from the instantaneous rate of change. All right, last example. So we want to find k so that this function will be tangent to this line. Okay, so there are 2 things that we probably have to do here. We have to make sure that the function is equal to each other because they have to intersect at a point. That's where the tangent line will intersect. Okay, and then we also have to make sure the slope of the function at that point has to equal the slope of this. Okay, so that's actually where I'm going to start. F prime of x is equal to 2x plus k. Okay, and then this one, the slope of the tangent line is 2. So f prime has to be equal to the slope of the tangent line. So this has to be equal to 2. Okay, now we can't solve that because we have 2 unknowns. So if you have 2 unknowns, you need 2 equations. So the other equation comes from setting f of x, x squared plus kx equal to this, 2x minus 9. All right, so now we need to figure out what we're doing here. I need to either get rid of the x's or get rid of the k's. Okay, so since each equation only has a single k, I think it's going to be easiest to substitute for k. So that's what I'm going to do. I'm going to solve this equation for k. So k equals, I'm subtracting 2x over 2 minus 2x. Now I'm going to plug that in over here for k. So x squared plus parentheses. So I'm plugging in 2 minus 2x for k. Now we still have that other x right there, and then equals 2x minus 9. Okay, so I'm going to distribute this x in here, so I get x squared plus 2x minus 2x squared is equal to 2x minus 9. Okay, combine like terms, so I get 2x minus x squared is equal to 2x minus 9. Move everything to one side. So we have a quadratic equation, so we need it to be equal to 0. I'm going to move the stuff on the left over to the right because I want my x squared to be a positive. So I'm going to add x squared. I'm going to write that first. If I subtract 2x, the 2x's actually cancel out. So I still have the minus 9 over there and equal to 0. Okay, you can either add 9 and square root, or you can factor this, x plus 3 and x minus 3, which leads you to x is equal to negative 3 and x is equal to positive 3. Okay, we're not done. Find k so that the function will be tangent. So we have an equation for k. K is equal to 2 minus 2x, and we have some x values right here. So we're going to do k of negative 3. 2 minus 2 times negative 3. That's 2 plus 6, which is 8. And then k of 3. 2 minus 2 times 3. 2 minus 6 is negative 4. So k is equal to negative 4. K is equal to 8. All right. May seem kind of counterintuitive that we have two answers, so I want to show y'all that real quick. I'm going to pause the video for a second to set it up. Okay, so I plugged in our equation here with our kx, and then here's our tangent line. So you can see our tangent line right here. You can see I put k is equal to 0 first, so that's just a quadratic parent function. So now if I just change my k to be one of my two answers, so negative 4 or positive 8, you'll see how it's equal. So let's do negative 4 first, and there we go. And you can see the tangent line. You can actually find that intersection point right there. Okay, there's the x value of positive 3 that we found, and you'll see the y value is at negative 3. Okay, if I do it at 8, there we go. Okay, I can't see it on this screen, but if I zoom out a little and scroll it up, there we go. So this one's also tangent, and they intersect at, let's see if I can get it to show up here. There we go. So there's my x value of negative 3, and then the y value would be negative 15. So that's why we got two answers, because there's two different parabolas that intersect this tangent line that are set up in this format, x squared plus kx. All right, that's going to do it for this video. Hope you enjoyed. See you for the next one.